Because of the vague definition of energy, the ability to do work, to put a force on an object and move it a distance, there are very many types of energy. The one I want to talk about today is the energy of moving objects, which is called kinetic energy. And I'm going to demonstrate the important parts of kinetic energy by doing work on these soda cans, crushing them, thus applying a force and moving their material a distance. I'm going to do that by dropping these textbooks. So, the first case, I'll just drop this book straight down. And we can see there was some work done on that soda can. I don't think it's any stretch to suggest that more work could have been done if there was more mass in the book I dropped. So let's try it with this book. Indeed, we get a little bit more work, although not that much more. So one of the things I think it's pretty logical to say is more mass M is more energy, more ability to do work. What else could I have done if I really wanted to smash these cans? Well, again, probably not much of a stretch. I could really slam them down. So we got that. And of course, the most work I get done. So what am I accomplishing by slamming the book down? I'm giving it more velocity. So more velocity. So more velocity is more energy. So what equation do we have for kinetic energy? It must depend on mass. It must depend on velocity. Well, it's not going to be super simple. If we just said kinetic energy was mv, well, we'd have a problem because first of all, we know mv is momentum. Second of all, that's not what we observe. We actually observed that changing the velocity has much more of an effect than changing the mass. So what does the equation actually end up being? It ends up being 1/2 mv squared. In the AP Physics calculus-based class, we'll go through where this equation comes from. In the other classes, we're going to have to live with its slightly strange form. And we'll investigate especially what the significance of that squared term is. But I hope you understand that the equation for kinetic energy does make sense and that it involves both mass and velocity.